box of pinhole camera of length L has a hole of radius A. It is assumed that when the hole is illuminated by a parallel beam of light of wavelength lambda, the spread of the spot obtained on the opposite wall of the camera is the sum of the geometrical spread and spread due to diffraction. The spot would then have its minimum size, say B minimum, when. Now, in this particular case, this is the aperture or the opening through which the light is going to enter. Since the wavefront are being disturbed by this slit, they will bend themselves. So here it is said in problem that the size of the spot that is obtained on the opposite wall, which is at distance L from this opening, is to be determined by the four options that are given to us. And the size is dependent on the geometrical spread as well as the diffraction spread. According to geometrical or ray optics, the light would be traveling straight over here, so this region would be the geometrical influenced region. But light, because of the obstacle, will bend from its original direction and it will further cover some more region. So this is the diffraction spread, we can say. It is given to us the size of spot is summation of the geometrical and diffraction pattern. So suppose this is the midpoint of the opening, that is slit, then this would be the size of the image that is obtained on the screen that is on the opposite side of the camera. It is made up of two things, that is the geometrical size, which will be equal to A, and let us say diffraction from this point, it is equal to Y. So summation of these two is going to decide the size of the spot. Now it is given to us that radius of this aperture through which the light is entering, this is aperture, it is equal to A. So obviously the entire slit opening will be equal to twice A. And further, let us say that the diffraction is taking place at angle theta. We know that theta is extremely small angle. However, it is to be also understood clearly that this entire part becomes the central maximum, and this is the first minimum which is obtained on the either side of central maximum. So the angular position of the first minimum is going to be important on either side for deciding the size of this central maximum. We can proceed in this problem further like this. Size of the spot, let us say this is the size of the spot, and this size of the spot will be equal to A plus Y, geometrical plus diffraction. Now we know from the trigonometry of this diagram that tan theta is equal to Y by L, but since angle is very small, we can simply write theta is equal to Y by L. So if theta is equal to Y by L, then that simply gives Y is equal to L theta. Now further we know one fact, that the angular position of the first minima on the screen is given by sine theta is equal to n lambda. So if we write sine theta is equal to n lambda, then we simply can say that a theta, because since angle is very small, we can simply write, and for minima n is equal to 1, so a theta is equal to lambda. B is equal to a plus, instead of theta we can write lambda by a over here. So this gives us the equation for the size of the image obtained on the screen of the camera. This size, minimum or maximum, is decided by taking the derivative of the size with respect to the variable, that is the opening. So dB by dA should be equated to 0 for the minimum size of the spot. On doing that, we get A is equal to root of lambda L. That means the radius of this hole, if it is equal to root of lambda L, then size of the spot will be minimum. Further, we also require to find out that what should be that minimum size of spot. So To get that minimum size of the spot, we will write B minimum, and wherever A is appearing, we have to replace it by root of lambda L. So B minimum is equal to root of lambda L plus L lambda upon A. There is again root of lambda L. On simplification, it will come out to be 2 root lambda L. And on further simplification, we can write it as root of 4 lambda L. So we can say that the size of the spot will be minimum when radius is equal to root of lambda L, and that minimum size of the spot will be equal to root of 4 lambda L. So correct option in this case will be equal to option C.